In this lesson, we're going to talk about similar polygons. So the key concept is that if two polygons are similar, if and only if their corresponding angles are congruent, so the angles are congruent, okay, and the corresponding side lengths are proportional, okay. So if you see down here, symbols A, B, C, D is similar. This is the little tilde here is the similarity sign. ABCD is similar to WXYZ. Okay, A goes to W, B goes to X. Okay, so A goes to W, B goes to X, C goes to Y, C goes to Y, and D goes to Z. Okay, all right. So the corresponding, so that those are the corresponding angles. The corresponding sides then are AB. AB corresponds to WX. All right. And if you do that, okay, so you go 15 to 5, which is 3 over 1. Okay. BC goes with so BC, that's the two middle ones, goes with XY. That's 12 to 4, which is 3 over 1. Okay. CD goes with YZ. CD, 21, goes with 7. That's 3 to 1. Okay. And AD, first and last, goes with first and last, WZ. 18 to 6 is 3 to 1. So all four of those sides have the same ratio, which means that they're proportional. So pause the video and copy this into your notes. All right. Next term 7.1, the similarity of the perimeters of similar polygons says that if two polygons are similar, then their perimeters are proportional to the scale factor between them. Okay. So if ABCD is similar to JKLM, then if you add up AB plus BC plus CD plus DA, distance all around this, and set it up as a ratio to JK plus KL plus LM plus MJ, that's going to have the same proportional as each of the corresponding sides do. Okay, so AB, same as the ratio between AB and JK, and so on for each of the sides. So pause the video and copy this into your notes. So our first example says to determine whether the pair of figures are similar. If so, write a similarity statement and a scale factor. If not, explain your reasoning. Okay, so we have to say that we have to determine whether all of the angles are the same. All right. Remember a couple lessons ago we talked about the fact that if you have two angles that are the same or that are congruent between the triangles, then the third angle is congruent as well. So here we can tell that all three angles are going to be congruent. Which when we go back to the thing, so to the very first one that you copied down, the angles are congruent. That's the first thing we got to check, and then the second thing we got to check is whether the corresponding side lengths are proportional. So in this one, we can say the angles are congruent. Okay. All right. So now we need to check whether the side lengths are proportional. Well, so 59, A goes with D. Okay. And 35 goes with F. Okay, so C goes with F. All right, so AB goes with DE, so that is 6 to 4. Okay, and if we get our calculator out, all right, we go 6 divided by 4, math, enter, enter. It gives us, this reduces down to 3 over 2. Okay? So the next one is 9 to 6. All right? Same thing. 9 divided by 6, math, enter, enter, is 3 to 2. Okay? And the last one is 10.5 to 7. All right? And when we plug that in, 10.5 to 7, math, enter, enter, and that means that that is the same too. So we can tell that all three of the side lengths are proportional. So yes, they are proportional, and the scale factor is 3 to 2. Okay. Next one. Determine whether a pair of figures are similar. Okay, so angle, that's congruent. These are congruent. These are congruent. And these are congruent. Okay, so we can tell that the angles are congruent. Okay, and it's pretty easy to tell. 3 to 7.5, and it's going to be 3 to 7.5 on all of those because we have a rhombus here and all the sides are the same length. And so that is, so all sides are proportional, and this is our scale factor. Right? Next one, we have two rectangles, okay? Two rectangles, and so they all have right angles on the inside. So we need to just look at the proportions. So 4 to 9, okay? So 4 to 9, I think probably is in lowest terms, okay? Yep, so that's 4/9. And the width is, so 10 to 18. And when we plug that in, and we end up that is 5/9. So this is not similar. Okay, these are not similar because this is different than that. Okay, so the ratios are different. So those are not, those two rectangles are not similar. Okay. Once again, we can see real quickly that all four angles are congruent. Okay. The angles are congruent, so then all we have to do is just check our ratios. So we have 12 to 6, which is 2 to 1. All right. 14 to 7, 2 to 1. We have 26 to 13 here and here, which is 2 to 1. Okay. And it tells us that the polygons are similar and wants us to find the value of x. So we say that the scale factor is 2 to 1 is equal to 13 to x. All right. So when we do that, when we cross multiply, we end up with 2x is equal to 13 times 1. So 2x is equal to 13 divided by 2. So our value of x is equal to 13 divided by 2, or 6.5. All right. Next example, it says we're already told that the polygons are similar. Find the value of x. All right. So the first thing we're going to need to do is figure out what our scale factor is. Okay. So if we look at here, this goes with this. Okay, because this is between the two congruent angles. This is between the 9 is between the two congruent angles. So we have 3 to 9, which reduces down to 1 to 3. That's our scale factor. 1 to 3 is equal to, okay, so the smaller one is up on top, so it would be 4 to x plus 5. All right, so we cross multiply. So 1 times x plus 5 is x plus 5 is equal to 3 times 4. End up with x plus 5 is equal to 12. Subtract 5. X is equal to 7. All right. And our last example that we're doing is we're already told that the polygons are similar. We need to find the value of x. All right. So m goes with s. All right. So we got to find the corresponding. We got to find the corresponding sides. All right. So when we do that, um, we can see that when we turn this around, okay. So 8. So the 8 and the 10, okay. When we flip it around, um, the ML, okay, goes with ST. All right. So the 8 goes with the x minus 1. All right. That means the 10 goes with the x plus 2. All right. All right. So cross multiply 8 times x plus 2. Okay. 8 times x plus 2 is equal to 10 times x minus 1. All right. Distribute. So we end up with 8x plus 16 is equal to 10x minus 10. All right. Solve for x. All right. We're going to subtract 8x. All right. Left with 16 is equal to 2x minus 10. Add the 10 to both sides. All right. And we're left with 26 is equal to 2x divided by 2. And we find out that x is equal to 13. All right. So that is the lesson on finding similar polygons and finding the different values of the variables used to that are used in similar polygons. So if you have any questions, make sure that you ask them to me, and we will talk to y'all later.